the Unacademy Plus subscription or Iconic will be having this batch, which is JRF Educators batch. Various batches I am announcing today, not only paper 1 and commerce and remaining other batches also, which is available from the 3rd of July. These batches are going to start. Especially me and Niharika ma'am will be starting paper 1 complete batch as well as paper 2 commerce complete batch course. So at Unacademy Plus as well as Iconic subscription plans. You can look at UGC NET paper 1 complete schedule, which is titled as an Ascent batch. This year for the December 2023 Ascent batch course on paper 1 complete all 10 units. This is a final schedule that you can see. So this is a schedule for commerce, all the 10 units in a detailed way, and as per the schedule which is going to be announced by the NTA for the December examination, once we complete all the theory courses, we will align with the next previous year questions on year wise or unit wise. Later revision courses will be announced according to the schedule of the NTA. So this is a detailed plan of the entire both papers 10 units. All these batch courses will be available at Unacademy Plus subscription or Unacademy Iconic subscription. Either of the subscription you can take it for the benefit of you. There is an offer which is announced by Unacademy. 25% discount if you take the subscription before the June 30. So 4,000 minus with a 25% off means 4,000 was deducted as a discount by applying my code Shiva Live, SHIVA LIV. I'll be putting all these batch links in the description also. Probability distribution, discrete series, continuous series, binomial distribution, Poisson distribution, normal distribution, most important part, and the pakka and the properties of these three distributions only question is going to hit. Right? Question is going to hit on these properties only. Let's see. There are two types of series by. Usually a discrete series as well as continuous series. Right? Continuous series. Continuous series is nothing but where frequency intervals will be there. Right? Now here single variables will be involved. To the point from the examination perspective, I will tell you, you will enjoy like anything the entire properties of 3. Within fraction of 15 minutes, I will complete the 3. Look at. Binomial distribution is nothing but, it will give you what? It will tell you either a success or a failure of an outcome in an experiment survey that is repeated for a multiple times. Like binomial distribution can be thought as simply a probability of a success or a probability of a failure in an experiment. Outcome is definite, outcome is going to come, either a success or a failure. Look at the example. By means a twice, means a double, multiple times, right? For example, coin is tossed like this. Possible outcome can be either it can be head or it can be tails. And taking the test could have two possible outcomes, either a pass or a fail, or a success or a fail. It can be of anything, right? So the two chances are very clear and equal chance of being occurred is there. Very clear, equal chance. Now look at the properties from this slide. There is a damn sure question which is going to be there in your pocket. 100% you can expect from here this question, this slide only the question will come. Please do not deviate and do not get disturbed by any of the unknown like unnecessary chart in the chat box. Just concentrate on the slide very carefully for the next 10 minutes. Look at number of trials should be very finite. Yes, number of trials are very finite. Whereas large number of trials also can happen, but finite. It is not indefinite trials are going to happen. Finite trials, 1 time, 2 time, success or failure. How many times you will make it? Infinite, not now. It is finite. Trial should be independent. First trial, second trial, there is no link. It both are independent in nature. There is no link and impact of both. and each trial is having only two possibilities. Every trial is only two possibilities: success or a failure, head or a tail. That's it. So sum of the probability in the binomial distribution, probability of a success plus probability of a failure is equal to 1. Probability of a success, that is P, denoted by the P. Probability of a failure denoted by the Q, which is equal to 1. Then can I say Q is equal to minus P, 1 minus P? Yes. Failure is equal to 1 minus success. Success is equal to 1 minus failure. In that way we can write it. Next, probability of outcome remains same in every trial, because either a head or a tail. Outcome, one will be one side, one other will be other side. 50-50 percentage of chances, every probability in every trial same type of outcome will come. One is head, one is tail. Right? Next is that for the binomial distribution, who is the hero for the binomial distribution? Mean. Mean is the hero of the binomial distribution. Mean as well as probability of a success are the parameters in the binomial distribution. Mean and probability of a success is the binomial distribution. Right? Now look at, that is why mean more than the variance. What is a mean formula? N into P. N into P is a mean formula, which is more than the variance. Variance is equal to NPQ. Variance is equal to NPQ. So that is, I would say, NP is nothing but, N is what? What is N? Number of trials that we have taken. P is nothing but probability of a success. Number of trials into probability of success is equal to mean. Right? Number of trials into probability of success is called mean. And when it is supported, when it is multiplied by the failure also, that will become variance. When the mean is multiplied by the failure, that is Q, NPQ, that will become a variance. So mean, the probability of a success multiplied by the number of trials, will always be more than the variance, that is NPQ. Variance is equal to NPQ, mean is equal to NP. Now symmetry of the distribution, look at the symmetry. When the distribution is symmetrical, probability exactly is equal to 50%. How much? 50%. 1 by 2 or a half. Or half, 1 by 2. 0.5 or 1 by 2. 50%. Symmetrical means in the middle exactly it will be. Like we know na, normal distribution. Like this. In the middle it will come exactly this portion. Here 0.5, here 0.5. In that case, that is a symmetrical distribution, binomial. Whereas negatively skewed binomial distribution is nothing but, when it is negatively skewed, P will be more than 5, means right side. But here only it is different by negatively skewed more than like 0.5, this will be more than 0.5 means more than half is indicating negatively distribution. Right? And first one is the equal distribution. Next, a positively distribution less than half. This is less than second, this left side. Rightly skewed negative and leftly skewed it is positive. That one. Next, a mean, which is x bar is equal to, it is also written as a mu. Right? And it is also written as an NP. It is also written as a mu. X bar is equal to mu, which is equal to NPQ. Which is equal to NPQ. And here standard deviation by variance is equal to square, right? And variance is equal to standard deviation square. That standard deviation square, variance is equal to NPQ, that we understood till now. Now standard deviation is equal to under root of NPQ or not? Obviously that will become, because square will become under root. That's it. These are the 9 properties which are repeated again and again, right? Again and again. Now look at formula for the probability of binomial distribution. Formula will be probability is equal to NCR into probability power R, probability of success power R, into failure, probability of failure power N minus R. NCR into P power R into Q power N minus R. This factorial NCR is indicating permutations related. How we can write that one? Permutation. Here n factorial divided by r factorial into n minus r factorial. How can we write? N factorial divided by r factorial into n minus r factorial into probability power r q into q power n minus r. Simply NCR can also be written in the way of a factorial. So what is this factorial actually? Suppose example is given 5 factorial. 5 factorial is nothing but 5 into 2 into 3 into 1. Sorry, 5 into 3 into 2 into 1. Where is the 4 went? Get numbers also. 5 factorial is 5, 4, 3, 2, 1. Both are different. Bernoulli binomial. Bernoulli, yes, Bernoulli and binomial both are same. Here I think it is written in the first slide. This is also called as a Bernoulli distribution. Not written, no? Okay. So 5, 4, 3, 2, 1 divided by r factorial will come. R factorial, r is nothing but a number of success. That is actually you are expecting as a number of success. That comes under the r. R factorial, that is in the given question we need to write in. R factorial means that one. And n minus r factorial is nothing but from the total number of trials r we need to remove, and that factorial we need to write it. Suppose this r is an 3 factorial, which is 3 into 2 into 1. And n minus r factorial is an 2 into 1. So now n minus r factorial, total 10 minus 3 3 by means a 7 factorial is an r, n minus r means a 7 into 6 into 5 into 4 into 1, like that we need to go. That comes under here. So with that will be multiplied. Actually practical area will not come, but remember the formula. Why to take a risk? Just remember the formula. Just remember the formula. Why to take a risk? Done. So here probability of r is equal to probability of a success. Probability of r is equal to probability of a success and in n trials, and probability of p is equal to probability of success, and the probability of failure is n q. Number of success actually expected. Number of r is a number of success desired. Number of trials actually undertaken is an n. The symbol factorial is indicating computed as follows: 5, 4, 3, 2, 1. 5 factorial taken as an example. Right? 0 factorial is equal to 1. Next, a Poisson distribution. What is Poisson distribution? Poisson distribution. Here Poisson distribution was given by whom? Poisson distribution was given by French mathematician Simon Denis Poisson. Simon Denis Poisson, and very similar to binomial only almost. Here binomial distribution deals with where number of success and failures can be counted, but uncounted number of possibilities will come. In the Poisson, events occur continuously over a given sum of period. Here distance or space, while the Bernoulli process events occur in the context of a trials. Here some of the examples of Poisson distribution will be number of telephones received per hour. It can be anything. Large number can be. Correct now? Large number of a telephone also, telephone calls also you can receive. And the number of fatal accidents per a week in a city, any number. And number of patients arriving at a health center per a day. And number of typing mistakes per page in a book. Number of cars arriving in at a toll booth per hour. So those are car arriving. Means at a toll how many number of cars are coming. So based on that we need to identify. Why this is like simply we can say, can I say this is an infinite number of outcomes, large number of outcomes, infinite number. In a simple terms, large number of outcomes are there, many possibilities can occur within a short period of time over one another. It will be having an infinite number of outcomes. Infinite number. It is not like a definite head and tail. It will be having a number of outcomes are infinite. It can be occur in a larger way. So let x be a Poisson random variable representing a number of outcomes. That is success in a given time. The probability of exactly r equal to is given as following formula as per the Poisson. So that is given in the 2020 examination. Probability of X, which is equal to R, that is a success that we are expecting, equal to e power minus lambda multiplied by lambda power R, which is the probability of success. Lambda power R means R is the probability of success, divided by R factorial. This is the simple formula. E is an Euler number. Euler number means the specific number is given by the Euler only. That very background reason is there why he given that one. So E value will be given in the question always. 2.71828 is an E value, exact E value. So that E value power lambda. Lambda is nothing but average number of outcomes occurring in a given, because we cannot able to calculate the exact one. That is why we will take the average. So in the average only, when the infinite number is occurring, how can we able to identify? That is infinite. Number itself, outcome itself is infinite. That's why we are trying to identify the average outcome, not the exact accurate outcome. That is e power minus lambda into lambda power R, which is R is an exact number of success. Lambda can also be written as M, which is a mean. Lambda is a mean actually. Lambda can also be written as an NP, number of trials into probability of success. Lambda can also be written as over here in this standard deviation square, that is variance. It can also be written as an, in the binomial distribution, mean is equal to NP, variance is equal to NPQ. But here mean and variance both are equal. Mean equal to variance in case of a Poisson distribution. So the properties of Poisson distribution will be discrete probability distribution. First, number of success like a 0, 1, 2, 3, it will go on, keep on going only, which are given in a whole numbers, not in fraction. There is no 0.5, 0.25, those will not be there, right? And value of the p value, success value is very less, because large number of infinite outcomes. Very small success will be there, that is 0. Even 0 success also can be possible. Q is high, failure is very lamba, because too much high population now, failure is very large, failure is highly large. It tends to be 1, and n is infinitely large. N is infinitely large. So value of p is tend to be small, even 0 also. Value of q is very large, even to 1 also. Next, main parameter. In case of a binomial distribution, main parameters were what? N and p, right? Sorry, mean and n and p are the parameters. Here main parameters is only one, that is np. Only one parameter, which is a lambda, that is a mean, and np is an probability of a success, which is probability of a success, and number of trials, which is an mean only. Main parameter is mean is the main parameter. There mean as well as p are the main parameters. Here only mean. Next, constants of a probability distribution. Mean is equal to NP is equal to variance is equal to standard deviation square. All are equal. This is the most important property of the Poisson distribution, right? Now standard deviation is equal to under root of the NP. This is there in the binomial as well as Poisson both. Next, a normal distribution. This was given by the, initially normal distribution was introduced by the Abraham D. Movie in the year 1773. Later this was extended by the Laplace. Some days after, Carl Friedrich also extended in the Gauss. Friedrich also extended this, Carl Friedrich Gauss extended in the 1809. That is why this is also called as a Gaussian distribution. Because Gauss is also there who extended. And this probability is fully, already we completed normal distribution in many of the times. This is speaking about a diagrammatic representation of the symmetry. Right? That is symmetry about the mean, showing that data near to the mean are more than the occurrence than the data far from the mean. Whether it is near to the mean or far from the mean, the proximity will be disclosed or revealed by the normal distribution. Normal distribution is applied when the number of trials are large and infinite. It is same as the case of a Poisson distribution, large as well as infinite. Number of trials are large, and tend to infinite also. Neither P nor Q. None of the thing is very small or very big. Both are normal. Whereas in case of the Poisson distribution, P is very small, Q is very high. But here both are 50-50 percentage will be there. 50-50 percentage will be there. That's what. Now let's move into the normal distribution. Properties of normal distribution we know very well. That is more important. Properties only. Questioning area, seedha properties they will ask. Look at it's a bell-shaped curve. Yes, it's a bell-shaped curve which is showing about the symmetry. This is a bell-shaped curve like this. You can see. My shape is going out of the bell. So this is a bell-shaped curve and middle line will be there, which is dividing into two parts. This is a 0.5 and this is a 0.5. Total 1. And middle one is called as an equal distribution, which is a symmetry, where mean, median, mode all are equal in the symmetry. And this is a rightly skewed and this is a leftly skewed. This rightly skewed is called as an asymptotic, whereas lefty is nothing but symmetrical side. These are half of the symmetry and half of the symmetry. This tail, whatever the tail which is coming now, which is not touching the x-axis, the curve it is slowly deeper is going now. That is what we call it as an asymptotic. I will explain over here. So it is bell shaped. Normal curve is a bell shaped and symmetrical about the vertical line through the mean, and it is a unimodal. Model means only one mode is available. Only single mode will be there. It tails extend to a infinity in both the direction, which is the curve is asymptotic to the x in both the direction. The curve is, now I was showing now that picture here this is what x it will not touch the x-axis because the curve is going like that only, like a railway track, but it will not touch the x-axis. It is same as like indifference curve by same like indifference curve only. Asymptotic to the x-axis is nothing but in the both the direction, whether it is this direction, left side, right side, in the both direction it will go, but it will never ever touch the x-axis. That's what the unimodal and asymptotic in nature. Whereas equality is indicating all the three measures of central tendency coincide, where mean, median, mode, all the three are equal in nature. And a range, the total area under the curve will give you the total probability of a random variable, taking the values between the -2 plus infinity. -2 plus infinity means here left side minus infinity to right side plus infinity. Like that, from that area to this area it will be moving. Total probability coverage -2 plus infinity. Right? Next, total area 50% on the left side, 50% on the right side. 50% on the left side and 50% on the right side. Next, equidistance of a quartile. 6th and 7th is most important. 6th and 7th. Look at equidistance quartile is nothing but Q1, Q3 are the equal distance from the median. The distance between the Q2 and Q1, which is second quartile to first quartile, which is a median. Second quartile is a median. And the same distance will also be there between the Q3 and Q2 also. Same distance, Q2 minus Q1 is having a same distance as equal to the Q3 minus Q2. Great, right click. Nice. Thank you so much for informing. So here Q2 minus Q1 is equal Q2 minus Q1, or Q2 minus Q1 is equal Q3 minus Q2, which is Q3 minus median equal to median minus Q1, which will give you the same equidistance quartile. From my place to your place is having a one distance, means your place to my place also same distance. That's what the same logic apply. Now the relationship of a normal distribution between the quartile deviation, mean deviation and standard deviation is equal to quartile deviation, mean deviation, standard deviation. Standard deviation is denoted by this one, sigma. Right? So mean deviation is equal to 4/5 of the standard deviation, whereas quartile deviation is equal to 2/3 of the standard deviation, or 5/6 of the mean deviation. By remember or by heart this one. I will give you the logic also behind it. It is given in the box, you can see. Mean deviation is equal to 4/5 of the standard deviation. Whereas that same quartile deviation also can be written in the way 2/3 of the standard deviation, or else quartile deviation can also be written as an 5/6 of the mean deviation. Right? Now how this ratio will be working? Quartile deviation 2/3 of the standard deviation. Yes. And mean deviation which is equal to 4/5 of the standard deviation. And another one is the standard deviation. Every component converted into a standard deviation. And which standard deviation gets cancelled over here. Remaining left over 2/3 is to 4/5 is to 1. 2/3 is to 1, 4/5 is to 1. Then when it is multiplied by the, when you do the LCM, we need to make it the denominator equal or not. So in order to make the denominator equal, this 2/3 multiplied by 5, 4/5 multiplied by 3. In such a case, 2/3 multiplied by 5 means that will become 15. 3 into 5, 15. As well as 2 into 5 will be 10. And 4/5 multiplied by the 3. 4 into 3, 12, divided by 3 into, divided by 5 into 3, which is equal to 15. That will become 12. Numerator will be 10 is to 12 is to, and remaining 1 will be divided by 15 and 15. That will be 15. So finally, if they ask the relation, what is the relation that we need to tell? The relation is that 10 is to 12 is to 15. Quartile deviation, mean deviation, standard deviation. One way of asking question. Second way of asking question is that mean deviation is equal 4/5 of the standard deviation. Quartile deviation is equal 2/3 of the standard deviation. This is, or else 5/6 of the mean deviation. Either way they can ask. QMS. QMS. Clear? Next, 7th or 8th property. For a normal distribution, coefficient of skewness is equal to 0 because thank you so much. Right click. Please do share it with your friends from Kerala. So share with your university friends also if anybody is there, so that I will also get motivated to do more and more as such. And do not forget to intimate if you get the JRF. My number is given in the WhatsApp. The Telegram link is given in the chat box, or else description you can go through with that and join over there and stay tuned to till the result. After the result also you can. So here mean, median, mode are equal. Here is the place. And these two properties are going to be most important properties. Listen. Skewness will be 0 because there is no skewness. Right and left skewness is not there. All are 0. That is why mean, mode, all are equal. The point of inflection of the normal distribution is denoted by x bar plus or minus standard deviation. So x bar plus or minus standard deviation is indicating a variable. Now look at carefully. X plus or minus. This is a mu, which is a mean, middle. Mu minus 1 standard deviation plus 1 standard deviation. Like this. The area is this one. Mu minus 2 standard deviation plus 2 standard deviation. That is second area, which is a 95.44. Next, mean or a mu minus 3 standard deviation to plus 3 standard deviation. That is this area. So first minus 1 plus 1 standard deviation area is that 68.26% of area. This is the PYQ. I am repeating again and again. Right? And mu minus 2 standard deviation to mu plus 2 standard deviation formula area covered is that 95.44% of the area. That is the second. Moving from this place to this place. Next, minus 3 standard deviation to plus 3 standard deviation is that 99.74% of the area. Okay. This is the area is originates from the, this implies normal distribution 68% of the observation lies between the minus and plus 1 standard deviation, and 95% lies between the minus 2 and plus 2 standard deviation, and 99% is lies between the minus plus 3 standard deviation. So the result shows that practically range of distribution is 6 times, although theoretically it is ranges from minus standard deviation minus infinity to plus infinity, it will be minus infinity to plus infinity, it will be there. This is the end of the distributions. 3 distributions. How it is? 3 distributions. Get done by. Questions, fatafat. Let's do the questions related to it and we'll move forward. Next. What are the features of normal distribution? Mean equal to 0, standard deviation equal to 1. Mean equal to 1, standard deviation equal to 0. And mean equal to 0, standard deviation equal to 1. Mean equal to 1, standard deviation equal to 1. Which one, Rahul? Which one you are asking? Option A is the correct answer because mean is 0, mean, mode, median all are equal and standard deviation is equal to 1. A. Which one of the following? Which one of the following is the characteristics of normal distribution? A. That is bell shaped and symmetric characteristics. Remaining, these are unequal, wrong. Total area under the curve of probability not equal to 1. No, it is equal to. Two tails are touches, never touches it is. The 2020 question, the standard deviation of the binomial distribution. Very easy, standard deviation of the binomial distribution. Under root NPQ, option D. Next, Poisson distribution, please calculate by. What is the Poisson distribution formula? Poisson distribution formula, which I remember, e power minus lambda, which is lambda power r divided by r factorial. Now can you able to identify? Easily you can able to identify. Please identify. If on an average, 2 customers are arriving at shopping mall per minute, what is the probability that in a given minute exactly 3 customers will arrive? 3 customers has to get it. Means the probability desired is that 3. Desired is that 3, which is a lambda. Sorry, r I think. After studying easier. No idea. Get idea, please. Calculate. Try by. I am giving a hint of the question also. It's a PYQ of 2020. You can't escape from here. How to calculate? One three five three. Lambda is equal to how much? 2 and 2 power 3. R factorial, which is 3 into 2 into 1. So can you give point 1353 power 2? Two cube is equal to this is 2 into 2 into 2. 3 into 2 into 1. The remaining portion is this one. How much it is this? Can you please tell? 0.1353 power 2 minus 2. Acha, okay, very sorry. Already given na. I am not looking. I am just applying the formula blindly. Okay, already given. Sorry. Extremely sorry. So 0.1353 into 4 divided by 6 or else 4 divided by 3. How much? 2 cancel na. How much it is coming? 0.3532. Option number B. Sorry, point 1 is given 18. By how much it is coming by? You are telling 2 as an answer. I am thinking that this outcome is that one only. 8 by 6 are 4 by 3 same na by. 2 4s are 2 3s are. .1804. Okay.